I am a mathematician, especially applied mathematician, and I think I am very happy that I decided when I was young, I was hesitating between mathematics and art. And I decided to study mathematics, and I am very happy about it because mathematics is a beautiful field. There are many kinds of different mathematics, but it's beautiful, and at the same time, along my career, I have discovered that not only it's beautiful, but it's useful also. And in our world, we need a lot of mathematics to develop new technologies, to advance the society, and so it's at the same time beautiful and useful. And I encourage young people to study, not to be afraid of mathematics. It's not more difficult than other subjects. It's just you have to like it, you have to work a little bit, but it's worth it. It's a beautiful subject. Thank you.
Okay.
So, like, is it the recording? Would you like me to take off my glasses, or? Okay. 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 Yeah. Okay. So, what should common people know about mathematics? Right. Yeah. Right. So. Okay, so the question is what common people should know about mathematics. So the first thing to know is that mathematics is not what is taught in high school. So there is a lot of beauty, philosophical beauty in mathematics that can influence the way you look at life. It would be great if high schools taught that side of mathematics. So I'm coming from a country, so Greece, where mathematics was intimately related to philosophy, and Zeno's paradox is an example, or mathematical logic is another example. So mathematics and philosophy are very tightly related, and mathematics can tell you a lot about your life. So I would like you to know that there's a lot of beauty, and that don't be afraid of mathematics, but try to look into it and try to find this rare beauty and truth underlying the developments in this field.
You have some particular aspect to it, some topic you should do.
So right, okay. So more like what I think, the side of mathematics that I am working on, and I think is particularly important and interesting in our times, is computation and machine learning, and the mathematical underpinnings of these areas, such as probability theory and statistics. So that is hugely important because in our times we are humanity is collecting a lot of data, and this data is being processed and informs the design of computer systems. And it's really important to know how this information is being processed. For example, are the conclusions that are drawn by algorithms by processing this data, are they reliable conclusions about the underlying phenomena? Is this data that is being collecting revealing private information that all of us are contributing to the creation of the data? So it's really important to understand how algorithms process information and to influence the design of computer algorithms that are driving everyday life. It's very important to understand, what implications that has about our everyday life. So that would be an important thing to actually explore.
Aspect. I think learning something about the relationship between numbers and shapes, learning to think about geometric figures and how we measure them, so that people can understand that that mathematics is not just manipulating numbers; it's about shapes and objects as much as it is about numbers, which are kind of a language. So I think it's important to establish that connection, so because people understand more things visually and physically than they do abstractly at that age when they're young. And so I think it's important to root mathematics in those kinds of physical things.
So my wish would be that people are empowered by mathematics. Mathematics has to do with thinking, with my own thinking, and getting results by my own thinking. So mathematics is the science which empowers people, which does not break them, does not make them small, but makes them big and powerful. Of course, today learning to calculate is much less important than in earlier times because we have the computers. But still, I'm convinced that understanding of numbers is of utmost importance. And this, in my opinion, has two components. One component is orders of magnitude, to be able to estimate orders of magnitude, for instance, of growth. So, on the one hand, and on the other hand, small numbers. Each small number has its own characteristic. It can be a prime number, a composite number, or whatever. So 7 is quite different from 6, so it's quite different from 8. And 6 is also different from 8, not in magnitude, but in characteristic. And this, my hope is that people should know.
Ok.
So, okay, stop.
C'est filmé aussi?
Ouais, c'est filmé. Ouais.
Là, 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 là. Et après, ça sera édité ou pas?
Ouais.
Ouais. Bon, je peux le faire en français
Ouais, ouais.
ou en portugais? Ça va faire
Parler en
quoi?
français, ça vous viendra plus naturel.
Oui, bien sûr, bien sûr. On peut y aller?
Ouais, ouais.
Bon, moi je pense que l'école primaire ou secondaire donne une vision des mathématiques qui est essentiellement le calcul, les formules. Et il me semble que, bien sûr, on a besoin de calcul dans la vie de tous les jours, mais je crois quand même qu'on ne donne pas assez d'importance à l'école primaire, même au CP. On ne donne pas assez d'importance à la logique, au fait que A implique B, c'est pas pareil que B implique A, et ça on en a besoin vraiment toute sa vie, mais tout le temps, tout le temps, tout le temps. Quand on voit le nombre de bêtises dans les journaux, à la télévision, ou parfois même de ses collègues, qui sont des erreurs de base. Je ne suis pas en train de proposer qu'on fasse de la logique formelle à l'école primaire, mais manipuler de manière élémentaire les règles de base qui remontent à Aristote, manipuler ces choses-là, je pense qu'on devrait donner plus d'emphase à l'école primaire. Ça va?
Ouais, ça va.
So tell me the question again. What should people know?
Yes,
About,
of elementary mathematics.
Well, this depends on the needs of people, of course. But I believe there's something essential that everybody should know. Everybody, at least who went to high school, should know about math. It is the purpose of math. What's the purpose of math? Math is completely intellectual. It tries to understand the law of nature, the outside world, the reality. So it creates a parallel world, but totally in brain. Nothing to do with experiments. So it's a model. For example, suppose you want to understand what is the resistance of a building to an earthquake, to what degree. You don't shake the earthquake. You don't shake the building for this. You do calculations. You do only, in your brain, you think, and then you make some calculations, and then you say the answer. So you are claiming that you understand the truth, the outside world, only intellectually. This is the purpose of math. And this is what I believe every high school graduate should know about math.
Mm-hmm. Okay. Yeah. Thank you.
I think mathematics is a very creative discipline, and for this reason it's very important to kind of understand the creativity behind mathematics, so try to challenge yourself with problems where one needs to develop its own ideas. So at the same time it's important to learn the basic mathematics of school and learn all the techniques, learn how to solve standard exercises, but at the same time try to understand what the ideas behind theorems, the ideas behind proof, and in order to start to develop also its own way of thinking. Mathematics is about imagination, it's about finding its own solution as well. So I think it's very important in general to try to, for instance, read proofs of theorems, even very general elementary proofs in geometry, in Euclidean geometry. These are a very nice things that can inspire the students in order to see how mathematics works. What?
You answered in English, it's okay.
Well, this is for what?
Oh, it's for, I'm from Federal University of Rio de Janeiro.
Right, you prefer Italian?
No, maybe you should prefer Italian.
No, I don't. It's okay.
Raphaël, premier. Tu vois. Donc ce qu'il faut savoir pour des mathématiques pour les enfants, disons, hein, jusqu'à l'école primaire, les premières années de collège. Il y a déjà, donc Étienne nous a dit qu'il fallait maîtriser les règles de la logique, il a tout à fait raison. Il y a aussi maîtriser le calcul. Les élèves ne savent plus calculer. Le calcul des fractions n'est pas du tout maîtrisé, alors que les fractions sont les premiers nombres avec lesquels les Grecs ont calculé quand même. Ça a une importance en plus par la suite dans le développement des mathématiques. La géométrie évidemment, ils en font très peu. Et les manipulations, donc en dehors du calcul, avec le calcul des fractions sur des objets concrets, évidemment les manipulations algébriques ne sont pas du tout maîtrisées en général. Donc c'est quelque chose qu'il faut aussi... donc la substitution d'un nombre dans une variable, c'est quelque chose qui demande, qui est très conceptuel, qu'on ne maîtrise pas. Donc, ça c'est pour le niveau élémentaire. Hein, voilà. Voilà. Non mais j'ai pas de... Voilà, en gros, ce sont des choses de base. Bon, il faudrait réfléchir davantage peut-être.
I think we should teach children about probabilities and how they measure uncertainty, because a lot of decisions in life involve reasoning about probabilities. Maybe not very precisely, but at least roughly. And I think it should be part of being a well-educated person to understand how to reason about them, how to reason about probabilistic events, and to use those effectively in your own decision making, because people can sometimes act very irrationally, and maybe by thinking about how to do decision making under uncertainty, they can be better decision makers. That's it.
I think one of the most important things that should be taught in mathematics is that mathematics is alive. That is not a dead science made by old people, but it's a field that is going on where people, even young people, can contribute to, a field that's ever changing, and a field that has relevance and impact to all of us and all our lives.
Probability. I think that even in elementary school, you can think about probability. Kids like it. It has problem-solving aspects to it. It has real-world aspects to it. When you make decisions, you have to think about probability. Humans are pretty good with probability, and it's been neglected. I think it's thought of as a topic that follows calculus, but I think that in the future that it's going to be so important and useful that it'll start to become more and more taught younger ages. So that's my one minute version of what needs to be done. More probability.
We have today wonderful computer software that's able to do things algebraically and with calculus to integrate and differentiate. And far too few people are learning to use that software as part of doing mathematics. And I think if they would develop facility with using all the wonderful tools that exist, they would find a much deeper penetration into mathematics would be much easier. So my advice is for you to learn how to use Sage and Mathematica, Magma, and the other wonderful mathematical tools that are now available to the younger generation.
Wonderful.